we talked about the atom. We talked about the fact that an atom has stuff inside it. At first, they didn't really know about protons and neutrons. The first thing they discovered was electrons. And then we talked about that plum pudding model of the atom. And we did the gold foil experiment and determined that that was a lie. So now we have this nuclear theory of the atom, which says that an atom is mostly empty space. We've got this thing in the middle called a nucleus. Inside that nucleus, we have protons and neutrons. These are subatomic particles. Protons are positively charged. Neutrons are neutrally charged. Then we've got all this empty space that is filled with electrons. That's the space that the electrons occupy. And I said the simplest model you can think of is kind of think about it like a solar system, where the nucleus is the sun and the electrons are the planets that orbit around it. That's not really true, but it's a reasonable way to think about it at first, okay? To kind of give you a sense of scale of what this would be. So think about the JSU Stadium. If the JSU Stadium is an atom, then the nucleus would be a marble on the 50-yard line, and it would weigh something like 100,000 tons, right? So it's incredibly dense, it's incredibly small, and there's all that empty space around it, right? So just to kind of give you a refresher here, charges work kind of like magnets, all right? So you can have a positive charge or a negative charge the same way you can have a north pole and a south pole of a magnet. And opposites attract, just like in magnets, all right? So a positive and a negative charge will attract each other. Two positives will repel, two negatives will repel. And a little bit different from magnets is when you have a positive and negative charge interact with each other, they actually cancel each other out, right? So they sum, they add up and cancel each other out, okay? So looking at these subatomic particles, the things that make up atoms, protons and neutrons have very, very similar masses. 1.67 times 10 to the minus 27 kilograms. That's tiny. We typically will look at things in terms of AMU when we're talking about a particular one atom or components of one atom, okay? That's called atomic mass unit. It's defined as 1/12 the mass of a carbon-12 atom, but that's kind of, we don't care about that right now, just atomic mass unit, okay? Protons, again, have a positive charge. Neutrons have a zero charge, a neutral charge. Neutrons are slightly, but only slightly heavier than protons. Now take a look at electrons. How many electrons would it take to equal the mass of one proton? What do you think? Just give me a ballpark. You don't have to actually do the calculation. So, say again? Yeah, roughly 1,000 is right. If you move the decimal place, right? So if we just look at that number and we start moving the decimal place here, that would be 10, 100, 1,000. So if we had 1,000 electrons, we'd be at 0.9 versus the 1.67. So if we had, what, 1,500 electrons, we're getting close, right? Electrons are, there's one for every proton in an atom, right? What's the biggest atom we know of? The biggest man-made atom that we've made has 118 protons, okay? So at 118 protons, that means we'd have 118 electrons. Are we getting anywhere close to the mass of a proton at that point? No. So we typically don't give a crap about the mass of an electron, okay? They are so tiny and insignificant, we don't care, right? If you're doing nuclear chemistry and nuclear physics, We care a bunch about the mass of an electron. But for the stuff that we're doing, we pretend like that mass doesn't exist, okay? Protons and neutrons are what matter to us. All right, so now we know what atoms are made out of. We can start defining different types of elements, because different atom types or different elements are defined by the number of protons that are in that atom type, all right? We call that the atomic number, and that has a symbol Z. So if we say something like Z equals 3, then we're talking about an atom that has 3 protons, and in that case, that would be the lithium atom. So helium, no matter what type of helium it is, it's going to have 2 protons, right? Aluminum is going to have 13 protons. That's how we define the type of atom it is. We haven't said anything about the number of neutrons. We'll talk about that in a minute. That brings up the concept of an isotope.